All right, so let's go ahead. Welcome, Master Bartek, as well. And okay, I think we've actually had a pretty good structure with Core Academy. Not to like toot my own horn on like, oh, how well we structured it, whatever. But I think in a way the hard part is done, right? Like once you get used to thinking in terms of vase mode and you start to get a feel for how the different parts of the system are communicating with each other and what the moves and events and these bits and pieces are, a lot of the other things about Urbit as a system are going to fall into place less dramatically. So we're going to talk about the boot sequence today, and this is sort of the last Arvo and more inner piece of the system that we really need to cover in Core Academy. Then we're going to step out and we're going to do some background on the runtime. We're going to talk about Ver, and in principle, we may talk some about Aries, but Aries has been moving fast, and so I think it's sort of hard to say anything pedagogically about Aries that would really be helpful at this point. And then once we have that, we're going to come back around into the veins and work through the veins. So yeah, that's pretty much the structure of what we need to do at this point. A lot of it's implementation now. So today's the boot sequence, and this dovetails nicely with the baby pill homework from last time and the ideas that we were looking at with, okay, how does Arvo work as an event processor? And so today, when we, so if you want, you can pull up an Arvo. We're going to spend most of our time in Arvo itself today as we do this. Get everything situated here. And okay. All right. So, all right. So we have Arvo. The formal, if you go back to the white paper, and in some ways, bits and pieces of the white paper have bit rotted over time because we've decided to take a different approach, structure, whatever. But most of the Arvo stuff is pretty sound, which makes sense because we're building an event loop. So the question that we're basically dealing with today is, if the formal state of an Arvo instance is a linked list of nouns as an event history from first to last, then how do we actually start that event history? Because part of that event history at the beginning has to deliver an operable Arvo, right? Like we have to produce the event loop itself that we're going to work on. And so there's going to be kind of this cycle that we're going to have to hit a couple times where we have to produce Arvo as an untyped kernel, as a raw noun, and then we're going to roll it forward into self-compiling source and then produce the kernel itself, the mature kernel, as the final part of that project. So if we go to, I pulled this already because it's a lot to look at. So if we go to well, actually, let's not even do the fake ship right now. Let's do the live ship because I think there's more interesting stuff going on with the live ship. Okay, so if I boot a new ship and I look at what's happening here, then we can see the processes where, first off, we essentially have this runtime boilerplate where we're saying, have we allocated the memory? Can we actually, if there's a peer present, can we load the peer? What happens as a result of these steps? Then there's a boot sequence proper, which takes Arvo into what's called the larval phase, which is an identityless Arvo that can't do a lot of things that full Arvo can do. And then there is a mature Arvo that follows that. And then we kick over, then we kick over to the main sequence and do all the user space startup and build everything that way and go from there. One moment. So, okay, anyway, so we start off here, we start the Urbit ship for the first time. What information do we have to provide when we start a real ship for the first time?
Networking keys, right?
Networking keys and the identity with which they are associated, right? Yeah. So both of those pieces to get this going. And that's independent of this loom mapping, and this is ivory pill stuff down here, where you're sort of saying, like, can I actually calculate knock events without reference to a core or whatever else goes on. Then you grab this pill. In this case, it mines a comet. I don't provide it keys, but because the comet doesn't have keys, the possession of the comet is the key. It downloads the pill, finds the identity, and then steps into this sequence here of puppy, can you stop growling? It's okay. I don't know if you guys can hear him growling or not. He's barking at the window here. Stop it.
Just a little bit.
All right. Okay, sorry. It's like he's distracted me. Someone came to the door while I'm teaching, and so he's distracted. All right. So okay. So we provide a ship name, we provide the private key. We could do this with a moon, we could do this with a comet or a real ship, whatever. So we allocate memory, we start this logical boot process. The runtime is going to start, the act of starting the runtime starts two processes. We directly start the keying process, and we indirectly start the surf process. These are both going to run for the entire lifetime of the Urbit process, but they have different responsibilities. When we are running Arvo as a noun, Arvo has a state, has interactions with arms and so forth, poking with nouns. This runs on the surf. The surf is the knock runtime. This is what used to be called the Urbit worker process. When you back when those came as two separate pieces, pre 2.0, whenever they made that change. It's in charge of keeping the keying up to date on the new state and shuttling Unix commands back out to the king. There provides a standard surf Urbit worker. Aries is a surf process. So this is all knock runtime stuff. The king, which is the part you start when you actually run /Urbit, is what manages the snapshots of Arvo's state and interfaces with Unix. So it handles the input-output from things. There is currently the only Urbit king. There was King Haskell a couple of years back. It was dropped for maintenance reasons because it turned out that the way the Haskell was written and everything, it was just going to be hard to keep this going. So your rule of thumb is your surf only ever talks to your king. So it's your Arvo to king communicator. And the king talks to both the surf and Unix. Well, so Matt says the surf is also referred to as Mars, whereas the king is Earth. That's like 95% true, right? Because the Earth-Mars split actually does move a little bit of responsibility around between them. And that's an envisioned way of resegregating the particular processes that are involved in this. It's actually been ready for a while, except for I think one bug, but it's not clear whether or not it's going to happen because it would actually make Aries as a surf a little bit more complicated for some technical reason I'm not sure about. Nikolai asks, why this split? Wouldn't there be performance penalty? I mean, I'm imagining at some point we probably empirically had knock running on the same process as everything else, and then there was some technical reason for coming back to this. Yeah, there might be IPC issues for this. There might be reasons that you want to start your surf, your knock runtime separate from your startup. I don't know. That's a great question for Joe or Phil. or Ted if he shows up to come back to that. So yeah, we should, like, I'm actually curious. It's a good question, but I don't know the answer to it. Matt, do you want to comment on that?
I don't know. It's a good question, but I also don't. Is IPC in general very slow?
I mean, I don't think it's particularly slow if you're on the same machine. There's no.
We probably have. I mean, the IPC is probably not the bottleneck, right?
Right.
The
Then you also
interpretation-
suggested keeping the IO separate from pure knock. Yeah, so there might be sort of like, I'm going to use the word aesthetic reasons and mean that in a certain way, right? Like reasons of code elegance might be easier that way.
I'm not an expert, but it seems like good architecture because you deal with memory management and input output, all these like, Unix, associated functions and interfaces in the king, and then just keep the serf strictly for giving work to and getting work back from, where work is, noun goes in, noun comes out.
Yeah, so Sidney Ladrat says maybe to allow separate kings for other OS types, e.g. a king for Windows. It's a possibility. Yeah, so I think this is good speculation, but I don't know the ultimate answer for why that decision was made. And it may end up being like it was a slightly arbitrary decision, but it's the one we live with now. That's a possibility too. In good C fashion, let's go ahead and take a look at in the var repo package var main.c and find the actual int main. They probably have it on separate lines. Yeah, there we go. C3i main argc argv. All right. So this is where you're actually going to drop in when you start the runtime for the first time. So it does its normal things, check your your command line options, check your commands, decide what it needs to do, and then it'll set some global flags and other things based on the way that it's going to be running here, passing these things around. Here's kind of your main mainline process here. So it's going to check your peer. These are still flag stuff. I am looking for, it is U3 king commence. Okay, so everything above this is checks and making sure that everything's there. U3 king commence is basically your runtime boot up process that gets everything going. All the everything gets handed over to this and then operated through U3 king commence. That is in, if I recall correctly, Dawn. No, oh no, it's in here, and then it goes to Dawn. All right, so start the daemon. All right, so you're going to see a number of references to UV default loop and UV loop. libuv is a library for asynchronous IO with just a system looper. So this is the library that's used to underlie everything, since every event in Urbit either comes from or results in a Unix system call. So this is the library that just keeps that going functionally as it runs everything. Then it's going to run the ivory pill. We'll come back to the ivory pill in a minute. And then after it's done all of those things, it's actually going to run the main loop and just let everything run here. So we're gonna look at the Bootstrap stuff in a minute. We don't need to. We're going to come back to the runtime next week and actually go through more of the architecture of what's going on here. And right now you're just sort of seeing more where are things moving around and why. probably one of the interesting pieces. So you notice King, where was that piece? All right, so King Boot Ivory. The Ivory pill provides some IO functionality that is basically present in the runtime. It's a pill, but you can run it and you can directly do some NOT calculations that you don't need to worry about elsewhere to keep things going. Dawn is what actually handles the key validation. So if we go back to the steps we were going through here, one of the first steps we do is we verify these keys. This is what Dawn is going to do for us as we run this. There are a number of operations that you end up coming back to for confirming comments and sponsors and other things. The main one that I wanted to start you with is U3 Dawn which is the Comet stuff. Okay, so this is going to mine a Comet. And so if you actually want to know, how do you know which stars are sponsoring comments? Well, this is provided in a jam file as a list, which is available online for you. So even to boot a Comet, you have to have an internet connection because you have to be able to retrieve this list of potential sponsors. And so when we talk about mining a Comet, what we mean is that there's a hard-coded list provided here of stars that are currently sponsoring Comets, and for whatever reason, we're not, worrying about the rest of them or other people sponsoring Comets. This is where that actually comes from. And then we're going to look at get jam just is our unpack everything. But DawnCom is what's actually running our Comet here. We're going to generate some random entropy. And we are going to spin up a contact to these stars and let this stuff run. So it is waiting on, U3DC is the part that is actually going to, based on the list of stars, it's going to do the negotiation until the keys are generated. You get the key. When that comes back, then you've found the Comet. You have the identity. See, we're extracting the identity, who is extracted from the seed, and you're able to proceed there. And yeah, it looks like we have some other junk there. If 0, so that's interesting. So actually, if you change this to true, then you can print and save the Comet private key explicitly rather than having to extract it from jail later on. That's a very interesting little side note that you're able to do that there. Anyway, okay. When you're looking at the runtime, there's a lot of, everything's going to end with U3Z. So everything is reference counted, which means anything you allocate that is an Urbit noun exists somewhere in your ship's loom. And so you have to free it explicitly when you're done, so you don't lose track of these values there. Everything that's prefixed with U3 in some way is tied into what's going on in your loom. So you have the conventional C operations like, fprintf to a file or what have you. The regular things that you'd run into if you're running C. And then you have this entire U3C logic that is additionally present as well. More on that next week, but you're going to see a lot of these. So these are just freeing the references after we're done using those pieces, and they've been passed into the system, whatever way you wanted to do that. The pure boot, U3 is the noun library. My understanding is that there was a U1 and a U2, and then U3 is the current version of the library. So it's just a version number. All right. And then peer is handling actually loading and operating your peer. Matt, is this where you ended up doing all the epoch work? Was that in this file, or is that elsewhere?
Disk.c was most of it.
Okay. What I'm looking for here is U3 pure boot. This is what is, if you go back to the King boot process after the Dawn. So Dawn handles your key negotiation. Are my keys valid? Do I have valid keys? Do I have comet keys? Whatever I have. That is this part of the process here. So if you have valid keys, then you can retrieve everything all the way up your sponsor chain. You'll be able to communicate. The step after that is to make sure that you actually have a peer. And if you look at the kinds of things that are provided to this here, configuration identity, I don't know that it even actually uses configuration flags. It passes them around. They're kind of a weird global construct that we actually pass to functions all the time. But anyway, the identity, if you're targeting a particular boot event or whatever, then you can include that in there. There's the pill that's going to be associated with it once we get the Bootstrap sequence. This is where it's actually going to trigger the boot sequence is inside of this. So that will be pure boot plan. Anyway, this is ball of mud, right? Like we're back in the spaghetti code of tracing this around. So we'll do more on this, but this is basically, we're creating the .urb file, we're creating the peer. Are we doing these kinds of things? Do we have any snapshots, check for replays and everything? If we already have a peer, then we don't need to start a new peer, but we do need to do similar kinds of checks. Are we, what was the last event in our event log? Does that correspond to the last event in Arvo? If it doesn't, then Arvo needs to be played forward. All of these bits and pieces. So now what ends up happening is you hook up the Bootstrap process to a supplied pill and then start the main event loop. That was the UV run that I referred to earlier. So this is that loop event handler. This is what the runtime is using as its loop event handler. And then Arvo has its own event handler that is emitting or receiving events that are being generated by the King via the surf. So that's your architecture as you look at everything up to this point. So now we have pills. All right. So the point of a pill, when you boot a ship, you need all the parts of the boot sequence that are not unique, as well as the private keys. We have those, and we need up-to-date information about the PKI, and we need some entropy. Having all of those things, the runtime can now start actually building and running in Arvo. Everything we've done before this point has not been Arvo. The Ivory pill has provided it some knock IO and so forth, so it knows how to jam or whatever it does that may not be jetted. So it can reason through those things. But right now we're still not running Arvo yet. Once you have an Arvo kernel, then you're just running and computing in the normal event time. And so the problem of bootstrapping, if you go back to the early language, it's bootstrapping. It's booting a computer is bootstrapping because you're pulling. It has to pull itself up by its bootstraps, right? Like starting from nothing. How do you actually turn a computer on? How does a computer get to an operable state? And on a conventional machine, you have ROM. You have a read-only memory chip that has some very basic instructions for where do I look in memory to load a font? Where do I look in memory to load what the actual bootloader options are? And then it can pass things over to things that are living in secondary or RAM and run those as well. For Urbit, what the fundamental problem is different. For Urbit, the fundamental problem is that you have to have identity and keys to get started. And you have to have the public keys of anyone you need to talk to. So that's why you've retrieved the sponsorship chain already. The galaxy table is provided for you, and so this one didn't read it all out, but you have noticed, you know, when you start an Urbit ship after leaving it off for a while, it'll read out the hard-coded IP addresses of where people are running galaxies. So once you have the sponsorship chain by construction, then you can get everything else you're going to need from Azimuth from the Ethereum node, because you know how to talk to your sponsor and your sponsor's sponsor. Okay, so now we're to the pill, and the pill is solving this problem for Urbit of creating an Arvo kernel, providing a list of moves to follow once the Arvo kernel has been created, and then a list of user space events which follow that setup. Now, the old boot process, if you go back and you run an Urbit ship prior to, actually, I can probably find this real quick. If you run an Urbit ship prior to probably 2.0, then you'll recall that it used to have an output that looked like this. All right, and it would play back these very specific pieces about, you know, what stage is it in the Bootstrap process, what's happening with each of these pieces here. And actually, I bet you still see this if you're running a brass pill and not a solid pill, because a brass pill doesn't force recompilation of the veins. So that may be the difference here, is that this was booted from a solid pill. We'll come to pill types in just a moment. All right, so the pill has a list of knock events to create an Arvo kernel. That's like the hard part, right? This is like, how do you do this in assembly language? Basically, that's the tier of the problem that we're doing. We're right here in the process. It has a list of the Arvo events. It has a list of user space events to follow everything. So, you know, if you look down here, you know, we get more logical boot. We've loaded jets. We've loaded memory. You know, everything agrees on what's available here on the Surf and the King, and then playback starts. And all of that compilation that I showed you in the old version here is basically rolled into this first step here, line 26, here replaying events 1 through 14. And since it's received as a noun, it's not providing everything. And then we metamorphose Arvo, we'll talk about that, and then we boot user space. Nikolai asks, what's the real difficulty in supplying Arvo to the runtime pill? Wouldn't one Arvo knock be enough? Yeah, so you'll see what we actually do when we supply it is we have the first 5 steps in booting this are canonical. Probably the most complicated part of all of this is injecting identity, because that does what's called breaking symmetry. And when you inject identity, now this Arvo is now unique from every other Arvo that's out there, because it has its own event history that is now different from everything else. Now, Joe is giving me some prehistory on what the boot process used to look like that I think might be instructive for us to come back to as soon as I talk about what the pills are. So let's come back to that. I think it'll respond somewhat to your question there, Nikolai. All right, so we have 3 types of pills. We have an ivory pill, which is this runtime support pill that just produces the Zeus code. It's the one I referred to earlier. It prevents needing to redefine certain parts of Hoon standard lib functionality in there. That's an ivory pill. You have a brass pill. This is a complete Bootstrap sequence. It includes recompiling all your veins against a target base desk. So if you're changing and distributing Arvo as a developer, brass pill is your complete Bootstrap sequence recipe. That's commonly the ones that's distributed. Depending on the size of the changes that are being made at any given point, you may also be using a solid pill, which is a kernel developer pill that doesn't recompile the veins the same way a brass pill does. So it can give you a faster boot up and you know, and then there's like a baby pill, right? Like the thing you made in the homework last time, which doesn't do anything, just crashes or no ops on whatever happens, but looks and acts like an Arvo shaped noun in many respects. Ivory, brass, solid, and baby are kind of the ones we have there. At one point, someone was talking about doing a clear pill as well, but I don't remember what the vision for that had been. And searching clear pill, I was unable to locate it back down. All right, so what do we mean when we talk about bootstrapping here? From the white paper, quote, before we plug the newborn node into the network, we feed it a series of bootstrap or larval packets that prepare it for adult life as a packet transceiver on the public network. The larval sequence is private, solving the secret delivery problem, and can contain as much code as we like, end quote. All right. So if knock is a frozen function from nouns, and it is, right, then we can define an OS. That OS, which is Arvo, guarantees that the state of your ship is a pure function of the things that have happened to it. So we know we're running 20302. Like that's our functional event loop. So the formula 20302 has to start with a first event. And this is the challenge, right? Like what's the first event? It has to perform the bootstrap of Arvo itself in sufficient detail that it can process the next event in the chain, event 2. So what we're actually going to do isn't going to be terribly different from what Nikolai suggested here of just running knock one Arvo as knock to produce it, right? Like we're supplying this. The problem is that this when identity is injected into the process. Okay, so I'll come back to this in a minute, but like sort of story time for a minute. What originally happened, if you go back to 2015, 2016 Urbit, when you were running destroyers and battleships and all these things instead of stars and comets, a destroyer was a comet. And you would boot a ship as a destroyer. And then you had a ticket. And you would send that ticket. Once your ship was booted, you would send that ticket to Tlon, and they'd respond with the identity key. And then you would apply that to your destroyer, and it would transform it into the identified ship. So identity was actually created after bootstrapping had happened, and very late in the process. And this had some interesting consequences. So for one thing, this was attractive from like a hosting perspective, because every Urbit ship was actually the same ship. You could boot, you could create the noun that is the common thing, and then apply identity to it later if you wanted to reify it into some particular instance, right? Give it that identity. And then for security reasons and some other things, they ended up injecting identity into the bootstrap sequence much earlier. And so that's called breaking symmetry. And when you break symmetry, now you have an Arvo noun that is unique from other Arvo nouns, and you can't treat it the same way as everything else. And that now takes place pretty early on in the event sequence. So that's why we don't just provide like, here's a fully formed mature Arvo, because identity is part of it. And since everything's deterministic, if you change one thing deeper down in your event log, like your Urbit is unique, right? Like it is now functionally different from everything else. Gary asks, does Arvo always hold its identity at the same tree address? I mean, I guess to the extent that we are grabbing it through a face, that kind of doesn't matter. I don't know that we ever grab it by address, even in the bootstrap stuff. So it probably does, but that's probably just kind of an incidental consequence of the design. Anyway, so let's go back and look at Arvo and actually look at what this event loop startup process is, and then we can sort of work back forward from there. All right, so let's go to, this is there. I want Arvo sys arvo.who. All right, we are looking for Eon. All right, Eon is your Arvo lifecycle loop. All right, the first 5 events in Arvo are designed to create the mature Arvo and just let the lifecycle function run. Everything starts through Eon, which is, so you can think of Eon as your first event, the thing that you're doing here. And as you work through this Eon core, you'll notice that it keeps having statements like this, like what we have here is a Tisgar, where this is now, we're gonna run this code down here, and you'll notice that we are zap-tizzing it. Like this is literally, we are generating knock code from what we have here. So we are just producing knock with our zap-tiz, and we'll get into what these pieces are, but that's what we're doing here. And then we are evaluating the kernel bootstrap, which is event 2, and everything else, which is events 3 through infinity after that. So in a sense, we are doing what Mikale suggested, right? Like we are just providing Arvo and then running this thing. Let me get the, there you go. All right, Mopful, you make it in. All right. All right, so, okay, so our first 5 events we're gonna go through. 1, we have to start the event loop. We're gonna do this in the Eon arm right here. 2 is we're gonna bootstrap an Arvo kernel from source. 3, we're gonna produce a Hoon bootstrap compiler. 4, we're gonna produce the compiler source. And then 5, we're going to produce the kernel source. And at this point, you now have Arvo as source, and you can run everything else against it. You're going to shed the larval stage. You've injected identity, and everything just goes there. Yeah. So, all right, let's see. So let's look at what's actually happening in Eon here. This is interesting. If you read Arvo, particularly these older parts, they were experimenting with literate programming. So I imagine most of this was written by Curtis, especially because there's Lisp callouts and stuff. So this is probably pretty old pieces of the system here. What's probably most challenging about reading this is a lot of the names of things have changed. So for instance, farther on down, it talks about spans, like pair span knock, right? A span is type, like what we call Lustbuck type now is span. So the comments have never been updated. And honestly, this code has probably not been updated substantially in a very long time, but here it is. All right, so here's Eon. All right, this is the first function run on any Urbit ship. This is what U3V boot is kicking you directly into when you load the solid pill or the brass pill. Here you are, congratulations, you're building your bootstrapped kernel. So these are the lines that we're actually interested in here. This Tizlus and this dot tar is grabbing this gate on the outer edge of Arvo. It's retrieving that. And since the formal Urbit state, as it says on line 727, is always a gate, which past the next event produces the next state, which is also a gate. This is what we're doing with this zap-tiz here. So we have been provided log, and so we're going to have Arvo and Epic. Arvo is your stateless kernel, And this is your kernel without any knowledge of identity or whatever. It's just basically 20302. Run this forward, and you can actually see related to what's going on here. We're pulling an arm and a core, but as we build this, we are just running down through all of the cells that have been supplied in Arvo. We're not doing it as just one Arvo as knock quite that simply, but we are just processing what are the pieces of this noun that produce Arvo, which is our stateless kernel. The pill null terminates that noun. And so when you reach an atom in epic, which is the remainder of your log for this particular event, when you reach that atom, you know that you've reached the end of the Bootstrap sequence, and you now produce the stateless kernel. And then that is what the event 2 and the subsequent events are going to be evaluated against with this Tisgar. Okay, so you're just going to consume events from epic one at a time until you have produced a full Arvo by evaluating the knock, literally .tar against the head of epic, which is kind of neat. Like, we actually don't even need to look inside and say, well, what's going on with epic? We can just say, like, yes, this is an event consumer, right? Like an event processor. All right, boot. And the rest of these start to get kind of they're all jammed together in the same arm here. But all right, event 2. All right, event 2 is to bootstrap a kernel from its source. So given Arvo, lowercase Arvo, the noun, we now need to produce the kernel from the source and start the main life cycle. So we're going to tisgal that, and then we're going to zap tis running these particular events here. And then we're going to lead into, so we have eon, boot, fate, hoon, Arvo, and then epic is whatever's left after that, right? The rest of the log. All right, so you kind of walk down through these and you see, okay, here's 1B, here's 1C. So if we go back to the old full output here, that's what's being played through as you go through these. Right, so 1C produces your compiler. Once you have the compiler, now you're running RIDE on everything. So RIDE goes back to lesson 2 when we're talking about how Hoon is built, right? RIDE is your end-to-end compiler. So this is the thing that, once we built it, we can keep cycling forward and running these components here. All right, so we are, let's see, we're zap tizzing, and that clause is going to run. Tisfaz, yeah. So your compiler tool is, yeah. So there's your compiler gate is .tar0 fake.log. So now you have actually your knock formula to produce your Hoon Bootstrap compiler. This is your final, like this is your actual piece that you're using to produce your simple compiler. Then you're going to compile that, producing a pair of, it says span and knock, but this is a pair of type and knock. So this is what we'll get out of running these things here. Then we will switch to the better compiler, which does better, right? So we can make things work more efficiently, more fast, whatever we need to do as we step back up the tree here. And then, yeah, once you've resolved these 5 events, you now have Arvo with source and type. Your subject is a type, like everything is there, and you can actually run your main event loop now. So this is your process for actually bootstrapping that kernel. Then when you're done, what actually gets returned back out is .tar of your compiler gate against in your kernel formula against epic.log, which is events 6 through infinity. Mopful, your question is, can you zoom in one? What does that mean? Oh,
Just make the text a little bit bigger. Sorry.
there you go.
Thank you.
All right, so let's step over to, we'll come back to the larval pill in a minute. I want to step over to lib pill, which you may have had occasion to look at when you were working on the baby pill stuff, but lib pill is a way of, it's all the bits and pieces that help you generate a bootstrap sequence. And so if we look at the brass arm here, then you can see how it's going to actually build this. So brass pill, you supply it a root desk like base, but it could be something else, right? We could, I mean, it used to be home, for instance. And then you supply it the secondary desks that you want to supply. And yeah, so I think exclude is there because they don't ship test folders anymore. I think that was the reason that was added there. There was a time when you used to get test shipped when you booted something, a new desk. Anyway, so if you look at what's actually happening here, it's going to return out a pill type, whatever that is, blah, blah, blah. You build your compiler source. You .ket directly into sys, the reference sys, which doesn't necessarily mean base. It could be something else. You grab that as the compiler source. You compile these things. You get your Arvo source. You get all these pieces. And then, yeah, you wrap them as ovums. Ovum is a pair of wire and card. It's basically, this is your raw event datum is what these pieces are. So it's just packaging these raw nouns as events for this to build from. Head tagged with pill and brass because that's what it expects when it loads the pill to have those things. If you compare it to Ivory, I think in one sense Ivory is a little bit clearer because it lays all these things out. Ivory pills don't do as much as brass pills. But it is neat to see we're doing a tis dot. We're just modifying the reference subject, which is a trap of a vase, by building Hoon, building Arvo, building Lol, building Zeus. And then for an Ivory pill, because you're trying to provide particular functionality, you build Ethereum and Azimuth in there as well. And then you package all this out and you hand this out as the final result there. One question: does this syntax still work everywhere? I know we used to have a similar syntax when we would run things when you define function types or argument types for gates, for instance, in old structure mode, old spec mode, then you would use the slash notation. And I don't see it anymore, except now that I like I've been looking at the kernel and I see it. So looks like that is still an alternative. It's an alternative syntax for head tagging with less.
I see that in Mark sometimes, pretty infrequently, but occasionally.
I think it's a very old syntax. Anyway, curious as far as that goes. Yeah, so this is building all these pieces line by line, which is here it's laid out very, very clear in what's going on. One of the things that I think is actually neat about this is we're building these in vase mode. We're passing out traps of vases and everything. So what is SWAT? A SWAT is a slap and a trap, which is a lot of fun to say, but it's a delayed slap. So you're building as a trap, and then once you've built everything, then you can kick it, zap, or well, you don't kick it, but you zap tis that quantity, and then that's what you actually put into the pill, is the knock that was constructed from that quantity. Just kind of a neat piece of how those are actually built there, as you put those together. Yeah, so like here's your explicit list in the brass pill of your first 5 events. That's where your first 5 events are actually built, as you look through the brass pill.
So a quick question, Neil, on
Yep.
Ivory. I thought that they were just for like building Zeus, but it looks like it builds everything. Did I misunderstand what they're intended for?
So my understanding is that the ivory pill is provided for the runtime so that it can do things like negotiate key retrieval without having to re-implement that stuff in the runtime. Like functionally, that's the intent of it.
Okay, so it's meant to like.
It's meant for this part, which is pre-bootstrap sequence.
I see.
So
it's meant to
basically,
bootstrap. Go ahead, sorry.
Well, basically, it gives you the ability to run wish against knock, even if you don't have an Arvo yet. You can evaluate knock.
Okay, so it does just like the most basic instantiation of an Arvo kernel.
Well, I mean, it compiles Arvo, but it never starts. It never evaluates the event loop in Arvo. Does that make sense?
I see. Okay, so it builds everything, but yeah, you can just wish on it.
That's it's just it's a ghost ship.
Okay.
Right, like it's built. It's built once they're actually. I like that.
That's a good metaphor.
Like you're never going to run the ivory pill directly, but you need it to save you complexity in the runtime.
All right, that makes sense. Thank you.
All right. So once you've been able to run down through these pieces, you've been able to evaluate, build everything. You run the rest of the event log, and you don't actually need just the Arvo source. Like you actually have to provide Arvo information so that it knows how to upgrade itself, or so it knows who it is, or what have you, right? Like it's not just, do I have this stateless Arvo? Like how do I actually get state into Arvo? So once you've parsed the pill, that gets you through, it gets you midway through this peer replaying. Well, actually it gets you through all of this, and then it gets you to metamorphosis. That's the end of that part of the bootstrap process. So Arvo is going to enter the larval phase. And at this point, if I Google larval, yeah, I get down here, and it gives you this little apologia explainer of what it is. But functionally, the larval phase is the outermost core of sys Arvo. All right, so it sits on the outside, and it provides this generic interface that is correct, but does not yet know about identity and entropy. So the larval core is supposed to accumulate the preconditions that are needed for main sequence or mature Arvo. And then once it has those, it will be shed and pass it. So it'll basically, you'll shed this outer core and you'll run everything as mature Arvo, which is the next core inside of your system here. Which is like kind of a weird way to think about it, but like functionally, this is what's going on with these core layers here. Arvo enters the larval phase under 2 circumstances. It does it once during the boot sequence, and it will during certain OTAs. So the boot sequence it does because it doesn't have any identity yet, or any entropy. It hasn't broken symmetry. In an OTA, if an OTA changes something from lol outwards that doesn't touch Arvo, so if it changes Zeus, if it changes a vein, if it's just user space stuff in base, whatever, then Arvo is not recompiled and this is not affected. If anything part or before in that core in lol, the first half of lol, or Arvo or Hoon changes, then Arvo will have to be recompiled and it will re-enter the larval stage to gather all the persistent and ephemeral state and any new upgrade state, and then hand that over to the new Arvo after the noun has been remade.
So the update process needs to re-inject the identity and stuff into the new compiled Arvo?
No, that part actually, well, I say that. I'm not actually sure I don't think it needs to touch identity, but I guess it probably needs to explicitly inject it into the new core when it goes into the new world.
Okay.
Because the new core that you're building from the instructions you got over the wire.
Yes.
So it won't know yet. So I guess it actually does have to re-inject at that point, but you could change it at that point. It's just that it would re-inject if I'm correct in that supposition.
Okay.
Which makes sense to me, but it's probably kind of a deep question in the way this works. All right. So the larval stage was introduced as a way to solve the practical problem and self-reference. If the ship isn't known, what should happen? All right. So if you're early in your system and you don't know your ship, if you're thinking about the way Hoon works, if you don't know the ship, well, maybe you bunt on the ship. But then what happens? Every ship is Zod, right? Like that doesn't work. So you could squat on Zod where 0 was just simply not a valid ship and not provide that, but that's not really a great solution. Another thing you could do is you could have a unit pat P. Everywhere that you talk about you have to have a unit pat P. You must have an identity. That's not good either. And so ultimately larval stage was what was come up with as the way of making sure that you can do things with Arvo before identity is acquired, but without making our completely a nightmare to work with in every other context. That's what had to happen here. No, unit identity would work. You could say unit pat P, but you would have to say unit pat P everywhere our is referred to forever henceforth, which would be a mess, right? Like everywhere you want to say our, you wouldn't say pat P, you'd say unit pat P, and then every time you wanted to talk about a ship, you'd have to need pat P, which would be a bad design pattern because it only matters here. It doesn't matter anywhere else. Everywhere else, you know you have identity. All of user space, you know you have identity. So, yeah, so the larval stage is going to be responsible for installing your standard library. So that's going to get you Zeus and veins. It's going to be responsible. Actually, it's not going to get you veins. Veins are next. Sorry, I misspoke there. It gets you Zeus. And then it gets you entropy and identity. And then it metamorphoses into the next stage of Arvo, which is when it sheds identity and goes forward there. So if you look at what's actually provided in the larval stage, there's a molt core up front and a what. We can skip over those. So here's the larval state itself. It has a load, a peak, a poke, and a wish. All right. Probably starting with the simplest of these first. What does peak do? Well, it returns the type of null. So you can't peek. Every scribe blocks. You can't peek into a larval core. It doesn't expose any information for you. It's opaque. You can wish, which may be useful when you're trying to calculate things. And this basically evaluates as normal. It just runs against Zeus if Zeus is present. If Zeus is not present, then it runs against Pit, which is the part internal before that. So it does make that decision based on whether or not you actually have Zeus yet, but It just reams it. Okay. Poke is your upgrade handler. Or I mean, it's where it's upgrade related events, right? It's your event handler. It's where you inject events. You provided a now, you provided an ovum. So an ovum was a pair of wire and card. So this is your cause and your effect in our old terminal, you know, the old way we were talking about it. But basically, it only really knows how to deal with verb, whack, what, whom, and word. And a verb and a what are events from anywhere. So that can be in the system or outside the system. A whack and a word are events from the runtime. So these are injected using like Lix IPC or Con or Clay or something else. And then a whom is your identity acquisition piece. So if you don't have an identity, then it produces an identity. If you do have an identity, it crashes. So you can't inject identity more than once. These are the things it knows how to do. Once it knows everything, and it's molted down, we'll look at molt in just a moment, then it's going to slog metamorphosis, and it's going to run load on itself with the remainder of this is the work list. And if we go to load, what does load do? Well, load just runs ket load. So it runs the load of its parent core, which is the inner core, which is mature Arvo. That's how you exit from larval state. So that's the exit process to get out of this stage of the bootstrap. Yeah, what is the upgrade engine here? Grub is the larval Arvo state, possible states, if I recall correctly. And so this is, yeah, kind of gross, terrible code in some ways. This is my objection to this part of the system, which, you know, we just have to live with it, is that everything is obsessed with 3-letter names. And some of them kind of make sense. Like I know what Zeus is. I know what Lol is. I know that Pit is like the part of the system before Zeus. But like, what's a gub? I don't know what a gub is. Like I have to go look this up. So anyway, it's fine. We'll live with it. But on the bright side, we actually probably never have to. Gub is even worse than I thought. Oh, it's what's gal up. Oh boy. On the other hand, I mean, it's pretty cyberpunk to talk about your code like this. It is a riddle. It won't be changed very often. Molt takes care of the process in a practical way because it gathers all your known system information and packages it for load. So this is basically just gathering up your bits and pieces and putting it together and handing it back over to load so it can pass it into the new world. So this is actually letting you build the new world and then pass up into it. All right, let's see. Yeah, that's the section 3BE core. Yeah, so once you have the outer larval core, once you've shed that through ket load, right here, right? Molt was here. Molt was invoked here. You know, gather up your work list, call load on your work list, and then jump up to ket load with the work list, pass it back up, and then that goes up to the load arm of the main sequence, and you're out. That's essentially what the bootstrap process is. Yeah, so you know, I've got a few more random comments on the end here, and I wanted to look at the shutdown process too, but like I say, this one ends up a little shorter, which is I think kind of nice for our pacing, because your homework this time is actually to just catch up on your homework up to this point in the class before because now that we've gone through all the Arvo stuff, we're going to pivot and start looking at runtime stuff, and it's just going to have a different flavor for a while. So anyway, let's see, Matt, can we check out how the Hoon compiler is bootstrapped? Okay, so if we run back over to pill, we find compiler formula, which is mint ut noun, mint ut now, mint ut noun compiler twig. So we are literally loading pieces up from the source and then providing those out. Now, what I should say is that I'm not actually sure what the difference is when we talk about the boot stage of the compiler stuff and then the compiler formula stage of the compiler stuff. If we go back to the events, so event 2 is boot, and this bootstraps the kernel from its source. Okay, so that's our piece here. All right, so compiler formula is supplying the Hoon compiler. Yeah, this just is Hoon, right? Because Hoon.Hoon is sufficient. So it's not like we're doing like a minimalist Hoon or something. Like this is Hoon, and we are literally loading Hoon from disk as a twig and then compiling it. We don't call these twigs anymore. This is a Hoon. Twig is like an old pre-Ford Fusion term. Does anyone remember when there were like 15 different Ford runes? Like there were horns and twigs, and you had to like pull them and compile them and everything. Like Ford used to be a lot more complicated than it is now. I think, I mean, there's faz what, faz hep, faz lus, faz tar, faz sig, faz tiz. And faz what is like deprecated. Like you could type it, but it falls through. It's a no op. So I mean, there's a lot fewer than there used to be. It used to be like faz hacks and fazbuck and a bunch of others. But Ford used to build like HTML and stuff. Like it used to be far more complicated than it is now. You know, it's probably a good sign. Like Arvo, like Arvo, Urbit as an operating system has in some ways been getting more complicated because we do things like add fine, but in other ways it's been getting simpler because it's trying to do certain things in a more straightforward way than they used to be done. Tiller says, I'm not phased by 3-letter variables, but grub meaning something different from grub and JSON parsing makes my eye twitch. Yeah, well, I mean, card is different, right? Like the card agent Gall is different than a Arvo card. There's a lot of places where, you know, we ran out of words, and you're just going to have to live with overloading when you get into kernel dev. Matt says, I think there might have been a lightweight Hoon compiler written in C used for bootstrapping, but it's no longer necessary. Okay. Interesting. I didn't actually know that. It doesn't surprise me, but I didn't know that. Yeah, and then Trent says, just ran into the card double meaning yesterday. Yeah, it'll trip you up. They're not quite the same thing. Yeah, okay. The other thing I wanted to look at, well, I guess, any questions up till this point? We have not yet talked about, we did talk about Zeus and Lol. We have not talked about veins other than vein interfaces. So we'll hit the veins after we hit the runtime.
I've got a quick question about the Arvo bootstrapping again, if I may, Neil. There were like 5 events. What are kind of like the broad intentions, or like we kind of went over them? There was like Eon, boot, and then I have written down Fate, Hoon, Arvo. I don't know if that's exactly.
It's these right here, right?
Oh, okay, yeah.
These are the 5 events as a list. So event 1 is start the event loop. So that's basically consume enough to build your Arvo. That was the Arvo epic thing. Event 2 is bootstrap your kernel from source. That's boot. Fate is event 3. That's produce the Hoon bootstrap compiler. Event 4 is produce the compiler source. That's Hoon. And then event 5 is Arvo, which is produce the kernel source.
The one quick thing about that is, so I can understand broadly what each of these phases like does, but what is the difference between like bootstrapping the compiler and then producing the compiler source?
Well, right here, compiler source is the Hoon source file, syshoon. Compiler formula is built from compiler twig. This is the actual knock.
Okay.
So what you do is you produce an event loop, and you use that to produce like an actual Arvo. So you have a baby event loop in Eon. You use that to produce an actual operable Arvo in boot. Then you load Hoon as knock, and then you run that to actually build Hoon from source.
I see. Okay.
And then you run that to actually build Arvo from source.
Got it. Okay, so you first have to like load the knock, and then use that knock to compile the actual Hoon.
Yeah.
Okay.
This is like you know that joke about the scientist who challenges God, says we can make life, and then God says, okay, well, let's do a contest. And so the scientist picks up the dirt, and then God says, no, your own dirt. This is your own dirt right here.
I see.
This is like how you do this from scratch, bedrock, nothing. The thing you do have to do though, and this is where it comes in through the larval phase, through the whom poke. The runtime does have to poke the larval stage with identity after the runtime has verified the keys.
Right. And one question about this really quickly is like, do you know what the security concerns were there? Like why? Like, because this to me, I imagine everyone else who's done like Urbit app development has experienced this. We have like a bunch of these fake zods. You can't like, there's no like booting up almost all the way and then like putting the identity at the end and then just, so you have to like make all these copies of like, Bud and Wex and whatever.
Right.
So like, do you know what all the security concerns were there that like they had?
I don't know exactly what was going on to do it.
Okay, just curious.
I mean, I think this may be a security concern in the sense that in 2016, when things worked this way, it was like on par with like, here, let me text you a message that's your private key sort of operation. Right. And this, could be done more securely than was actually done at the time. But, for right now, like this is the way that we actually handle it, is we inject identity here. When we shed this core, identity is now part of your system. So by event 5, you have identity, you've metamorphosed and you're on your way.
It's interesting that it's like you can't actually have a working Urbit without an identity. It's kind of like, maybe that was like part of what went into this decision, but like you can't really have a ship of any recognizable, because it has to do this like molting, or it has to go through the larval stage first, right? And that's when the injection happens. So
well, your baby pill didn't have an identity, right? You can have an Arvo
without
an identity.
I guess you can have an Arvo.
You can have like an Arvo shaped noun without an identity, but not necessarily a full.
I mean, your baby pill didn't have an identity, right?
Yeah. That's what I was saying.
Oh yeah.
Yeah.
But like the problem is like, what do you do with identity if you don't have identity?
And this is what you're talking about with the unit PEP, right?
Right.
For R and okay.
Right. Like, you don't want it to crash because that would be unworkable, but like, what else do you do? Question, could an evil pill extricate private keys from a ship? Yeah, you could imagine, I guess you could imagine a pill, getting a poison pill that would have an event that would extract and then transmit your key, receives it from the runtime and then transmits it, does something like that. So, that's this goes back to the old Ken Thompson paper, Reflections on Trusting Trust, which is basically a dramatic and interesting demonstration. It's worth reading if you've never read it. It's technical, but it's quite comprehensible. But he basically shows that if ever your compiler is compromised, you can literally never trust anything produced by that tool stack again. So, if you had that problem, if you ran a poison pill, which, you'd have to figure out, like, how would you actually get someone to run a poison pill? But if you did, then yes, you've created a huge problem. Because you could grab things and then that ship is permanently compromised until they just breach and move on. Teller says Zorp's prover is an Arvo-shaped noun without an identity that runs on Aries. Right, yeah, so you don't, right. So you can run something that has a peek, poke, wish, load setup. And the UV run can inject events with poke from it, but it's not an Urbit ship in that it's not talking on aims to other Urbit instances. A side comment about the veins. The veins have a definite boot order too. I didn't get into that here because we just haven't talked enough about the veins to really motivate it yet. But like jail and dill are among the very first veins that are started, because you need to know things like identity, right? Like can you actually communicate on the network? Aims is early. Other things like Gall are really late. Like you don't need Gall until like you're actually ready to run user code at the end of the day. So there is a defined order of startup for the veins that needs to take place. But like I say, we'll run into that incidentally as we go through veins in more detail. All Hoons are compiled by pills, compiled by pills, compiled by pills. Urbit's trustworthiness cannot be verified. Yes, very dramatically, if you wanted to do this, you would need to implement by hand an Urbit compiler, implement a knock machine in Forth on controlled hardware on a chip that you built yourself, and then start up from there. Okay. The other thing I wanted to look at then was the shutdown process. Oh, LE might be worth looking at too, real quick. This is the event loop engine. It provides an abet pattern core for your peaks and your pokes and everything, and it's useful for handling things in the larval and in the mature stage, but it's just a core that actually processes running these events and building them into the abet pattern. So stacking up all the moves and adducts and putting all this forward. So it exists kind of like VA. There's not a lot to say about it. It's just another one of these operative engines. What is interesting is this the same? Yeah, this is the other what. Yeah, so what is what takes care of, do you have a kernel update? Do you have a continuation of a kernel update? Or are you just updating the modules, which are the veins, which are the pieces outside the kernel? Lol Zeus and the veins. So kind of neat there. All right. Let's see. We talked about metamorphosis. We talked about main sequence. We talked about veins. All right. So let's look at, let me run back through this real quick. All right. So then when Gall is, all the veins have started up, Gall starts up, then it starts everything. And Hood is your user space agent handler. So you're going to run into it again and again as you run things. And man, there's a lot of junk that, you have to start everything, but everything gets announced. That's why it looks long. So when we actually run something with a bar in front, it's a Hood command. It's a generator that is in Hood, and then it gets passed into Helm or wherever, Kiln. These are all these agents that are built together work with Dojo. So if we go to exit, it generates a drum exit. And we say, okay, what's a drum exit? Let's find where that, yeah, there it is. So that generates a poke exit. And this generates a dill quit. All right. So bar exit is morally equivalent to typing Control C, or I guess Control Z. Let's see what it actually favors there. So that's in dill here. I guess it's in the interface here. Yeah, so that's your closed console. And anyway, at some point it propagates back up to your close everything and do it. Then to bring things full circle, if we go all the way back to the king, once you're done running your event loop, then you do a cleanup after your event loop, which actually right now does nothing. Interesting. Should it do something? Maybe. And then it tells U3M is the Mars handler, so that's some of your surf stuff. I would be surprised if this actually doesn't just pass through to surf. Or maybe that's main. Problem with having too many of these. Oh, there's U3M stuff. Okay. Actually, I don't know where that's where that one's coming from. Oh, manage. Okay, so that's one of the managements. Okay. Anyway, yeah. So this shuts down some of your crypto jets and other things. So at the end of the day, then this is why your runtime actually needs to notify everything on shutdown and then take care of closing out your event log and you're shutting down your surf process and everything. And then you're done. You've gone full life cycle, beginning to end. Mopful, what's a born failure?
So when you boot up a ship, so whenever you boot up a ship, Ver sends a born card to every single vein. That card basically tells the vein that, hey, you restarted. Send me information you need. If the vein doesn't exist, or if it fails, it'll just fail. In this case, the vein doesn't exist because you're not running 412. If you type in Zeus.
I guess I'm running 212, which would have gone to 413.
Yeah,
because the pill for 4. Yeah. Okay.
Yeah, type in Zeus really quickly.
No, this isn't running.
Oh, it's just output. Yeah. Okay.
This is just output.
Yeah. So because you don't have 412 yet, it would have.
Okay, that makes sense.
Yeah. So what interesting thing is we had to So all lick does is it sets the Unix duct. So this is the duct where it sends cards back to var. And so we had to basically bunt the default card, and Joe wasn't very happy about it, but it was the quickest solution that worked. Technically, you need to do like a Vega and all this other stuff, but not worth it.
Yeah.
For this, yeah.
Cool. All right. Yeah, so let me, yeah, I mentioned, so this is kind of the end of the first arc. So the next two lessons are there. Then we start veins. Then we take like a 3-week break. Or we take 2 weeks off. So, 3 weeks for assembly. Then we do more veins, more veins, more veins, more veins. And then we close out on azimuth on the far end. And we do IO drivers too in the runtime at one point. So yeah. And even at that, there's still a lot of topics that I wrote down that I wanted to get into that I have not, we're not going to fit. Like I actually want to get into Aqua and Pyro, but we're not going to be able to fit it. There's just too much already going on in here to talk about. So it's a good problem to have. Someday one of you will sit down and figure out Aqua and Pyro and what to do with them and how to maintain them.